Okay, so sine of x over 2 then, and the final answer for this one then is positive, because sine is positive in quadrant 1, so I don't have to write a plus sign. Big square root 1 add square root of 8 over 3 and divide by 2. Negatives make a positive. Cleaning it up, make the positive sign in front. And I will clean it up to the book answer. All right, so number 2, try to keep the same pictures up. We want cosine of x over 2. And that would be plus or minus big square root 1 plus cosine x. Divide by 2. And that will be equal to plus or minus big square root 1 plus, and cosine of x would be, well, I've got it written right here, negative root x1 plus a negative root 8 over 3 over 2. And the same idea, I've already divided thing in quadrant 1, and cosine is positive in quadrant 1. Positive in quadrant 1. So again, a cosine of an x over 2 would be a positive, and you'd actually have 1 minus root 8 over 3 over 2. There's a plus in the formula, but the cosine's negative. And so that gives you, a negative 1. Let's see, here we are. It gives you 1 minus root 8 over 3 in the cosine, and the 2 negatives turn it positive in the sine of x over 2. And I don't know, it just strikes me just a little too complicated to go sine of x over cosine of x over 2. So I'm just going to pick out one of the tangent formulas, probably the first one, x over 2. I should have it memorized. I'll just pick the first one. 1 minus cosine over sine of x. All right, so that's going to be 1 minus, and cosine of x was negative root 8 over 3. And sine of x was given to be 1/3, or if you can get it from the cosecant, over 1/3. So you can clean this up a little bit. 1 plus root 8 over 3 over 1/3. That's going to be 3 plus root 8 all over 3 over 1/3. Can you tell? Oops, look at the screen. Okay. Can you tell then the 3 flips around, cancels, and so you add 3 plus root 8. Tangent. You might be able to see it if you divided by this. You kind of tell the 2's are going to cancel. I don't know, it's hard to see in your head. So to me, this is much easier. That up a little more. Leave it up for a little bit in case anybody wants to stop on it. All right, so yeah, a bit of a project. All right, we'll keep working our way through. Let's try 45. A sine of a half of an arc cosine x. All right. Well, this is like a sine of u over 2, and so your u is the arc cosine of x. So that's going to go, sine of u over 2 is going to go plus or minus big square root 1 minus cosine of x all over 2. All right, and the u, yeah, is like this. So that's going to go plus or minus big square root 1 minus a cosine of arc cosine x. Squeeze that on. Hard to see. I'll rewrite it again here. Plus or minus big square root 1 minus cosine of arc cosine of x all over 2. Well, these are going to cancel, and you're going to wind up with plus or minus big square root 1 minus x over 2, because these are going to cancel. And you can't even really pick the plus or minus or anything off of that. They might just use plus just to make it. But there's nothing really, no information really given to pick between the two. Okay, why don't we try 49? Through a lot of different kind of formulas that you get all in this one section. Secant of a 2 of an arc sine of 1/4. We don't have any formulas for secant of a double angle, so you're going to write that as 1 over cosine of a double angle. Well, this is like your u, cosine of 2u. All right, remember 3 different versions of that. We'll go with cosine squared of u minus sine squared of u. That's going to be a cosine squared of your arc sine of 1/4 minus sine squared of your arc sine of 1/4. All right, now this is going to be the easiest one, but maybe it's hard to read off this notation. Particularly this one. All right, this is saying that you're basically going to take, well, let's just say minus your sine of really arc sine of 1/4, and see, then you're going to square it. And these are going to cancel. You're going to wind up with minus 1/4 squared. These are going to do each other, but you got to square it minus 1/16. Let me think. This is all, I've kind of screwed this up a little bit. I really lost the 1 divide. I'm really kind of working this out on bottom. And I really kind of lost the 1 divide. Now I'm working this out on bottom. I'm getting this piece of it to be minus 1/16. This, well, okay. 1/4 opposite over hypotenuse. 16 minus 1 is square root of 15. Cosine is root 15 over 4. So this is going to be a root 15 over 4 quantity squared. And again, it's 1 divided by all of that. So you're looking at 1 divided by 15 over 16 minus 1 over 16, which is 1 divided by 14 over 16, which flips around to 16 over 14, which is going to be 8 over 7. I haven't checked any answers. I've got no pride. 7/3/49. I don't care if I look like an idiot. Yep, there we are. (49), can you read it? 8 over 7. All right. How about 53? Sine of 2 theta, and the sine theta, 1 over 7, quadrant 2. Quadrant 2. See, that's your theta around. Opposite over hypotenuse. 49 minus 1, that'd be a negative square root of 48. Can y'all do those in your head? Square that, 49, square that, still 1. Subtract them. 49 minus 1 is 48, and you need a square root. Quadrant 2 would be negative. A sine of 2 theta, it's really plug and chug. Twice the sine, cosine. Twice, your sine was given to be 1 over 7, but you can get off the triangle 2, because of kind of going backwards. You do the triangle from this, but that's 1 over 7, and your cosine is a negative root 48 over 7. Giving you a negative 2 root 48 all over 49. It's possible the book would, I mean, you could go root 4, root 12, I mean, you root 16, root 3. Yeah, it's possible the book would simplify that root 48. What would you have? You'd have a negative 2 square root 16 square root 3 over 49. Root 16 is 4, so that's a negative 2 times 4 root 3 over 49, which is a negative 8 root 3 all over 49. And 49 don't cancel, so. But, I would take this. All right, then we go into sum to product, product to sum formulas, and finally identities. All right, let's go. Let's try one like 57. Still on page 597, 57. Cosine of x and a sine of 4x. I definitely don't have these memorized. Page, we'll speed them up a little bit. You're going to cosine times sine. Okay, that's number 2 here. You're going to half the sine of the sum minus the sine of the difference. You're getting a big 1/2. Cosine times sine. Sine of your x plus 4x. Sine of your x minus 4x. You're getting big 1/2. Sine of 5x. Sine of a negative 3x. And this comes out. Sine is odd. 1/2, a sine of 5x, add a sine of 3x, quit. These are unlike. No idea how many people get sine of 8x out of that. All right. How about 63? Cosine of 4x, cosine of a 6x, cosine minus a cosine, that'll be the last one there. So a negative 2, a sine of the average, sine of the difference divided by 2. No real name for that. So you would get negative 2, sine, and you'd add them up. By 2, sine, and you subtract them, divide by 2. Giving you negative 2, a sine of, I'll write out all the steps, 10x over 2, sine of a negative 2x divided by 2. Giving you a negative 2, a sine of 5x, a sine of a negative x. Again, this would come out. Sine is odd. Positive 2, a sine of 5x, a sine of x. I wouldn't mark this wrong. If the book shows this is where they're getting it. How about one like 69? Man, there's a lot of little sections in this section here. A cosine of 37.5 degrees, a sine of 7.5 degrees. Back to product of a cosine times sine, that'd be number 2 here. Big 1/2, sine of the sum minus sine of the difference. Big 1/2, sine of the sum, 37.5, adds, how much you want to bet? That's 45. I think it is. What was the sine in the middle here? It was cosine times sine, cosine times cosine's number 2, minus, there's a minus in the middle, sine of the difference. But you bet that's 30, yeah. 5 degrees. So you get the big 1/2. 45 degrees, subtract sine 30 degrees. We can work those out because they are circle numbers. Over 2 minus 1/2. If you want to clean that up, root 2 minus 1 on top. You'd be all over 4. With that 2, you'd be all over 8. I'm sorry, 4, my fault. God. This would be root 2 minus 1 over 4, and then you get that. This would be root 2 minus 1 over this 2 times that 2 gives you 4. Got to slow down. Think. All right. Prove identities. I think I did 73 and 75. Remember right? Pick out any new ones here. How about 77? Verify that a twice tangent x over 1 plus a tangent squared comes up to a sine of 2x. Well, I mean, there's several ways you could go. I convert to sines and cosines here, but I could also realize 1 plus a tangent squared, that's equal to a secant squared. Then I can convert to sines and cosines and see if I get anywhere. So if I go twice tangent over secant squared, now I'll go to sines and cosines, twice sine x cosine x over 1 over cosine squared, 2 sine x over cosine x, cosine squared x over 1, because you got to flip that around, equals, okay. Cancel that one. This gives you 2 sine of x, cosine of x. On the other side, that is the definition of sine of 2x. You could write sine of 2x here equals sine of 2x. Or you can stop when it's clearly recognizable formula. Okay. Give a few more here. How about one like 81? Might make this last identity and then do one of the last ones here. Sine of a 4x, sine of an x, comes up a 4 cosine of an x, a cosine of 2x. All right, now that's a product of cosine, and you could somehow use your, I don't think you're going to turn it into a quotient. There's no formulas for sine of 4x. But what you can do is bust up 4x. Say 4x equals, say, 2x plus 2x. And then use your formulas. So I'd have a sine of, and then there's several ways. You probably do a 3x and 1x. You get there. But I'm not doing that because I don't have any 3 x's over here. I've got 2 x's in x. So I'm going to try it this way, over sine of x. Now remember, you busted it now up into 2 pieces, so you have formulas for that. That goes sine of 2x, cosine of 2x. Remember, it went sine, cosine, and then add cosine first, sine second, all over sine x. I'm trying to turn this into my 4 cosine x, cosine 2x. All right, well, now I got formulas for double angles here. So how about a sine of 2x, piece 1, I'll just number them piece 2, piece 3, piece 4, otherwise the gibberish is going to get. Piece 1 is your sine of 2x, that's twice sine x, cosine x. Piece 2, let's use the first version, cosine squared minus sine squared. Add, all right, piece 3 is another cosine minus sine squared times then piece 4 is your twice sine x, cosine x. This is like formulas galore here. They're almost identical. Well, they are identical, actually. You could kind of combine them and double the whole thing, but they are identical. They're just switched in order. Let's go ahead and write out, all right, twice sine x, cosine cubed. That's this times this, minus twice sine cubed, cosine. So your sine times sine squared, your sine cubed. Add. That's a cosine squared. Sorry about that. Cosine of 2x is cosine squared minus sine squared. So you're going twice sine and then cosine cubed. And then minus twice sine cubed cosine. I don't know if this is getting us anywhere or not. All right. I was hoping some things would cancel, but they're actually doubling, which makes sense. This whole thing up here should double this, meaning twice 2 sine cosine 2 less 2, that's a 4 sine x cosine cubed. And then minus 2 of it, I lost an x in there. Minus 2, that's a minus 4 sine cubed cosine. All right, pull out a 4, single sine, single cosine. I think we're getting somewhere. That leaves a cosine squared. Minus sine squared. Yeah. Okay. Doggone them off. I've got my 4, my cosine, and this is my cosine of 2x. Oh, it was divided by, I lost my divide by sine x. Bingo. Okay, so divide by, I got it here, divide by, so this was divided by sine x. All of this was divided by sine x. So all of this was divided by sine x. So all of this was divided by sine x. That gets rid of my sine x, and there is my 4 cosine of x. And cosine, I'll still write here, minus sine. And all of this is equal to my cosine of 2x, which is equal to my right side. or cosine x cosine of 2x. Right there. That's how you got rid of that darn sign. I was getting down here, I couldn't have forgotten, but I lost my divide by sign. That's how they get rid of that extra sign there. I'm sure you want me to put a whole bunch of those on the test, right? Yeah, sure. All right. Let's try 99. We'll make that the last one if anybody's watching this far into it. Take a sine of 45 degrees and add a sine of 15. That's some fits with 97, so we'll see. And that's supposed to be equal to a sine of 75 degrees. Okay, let's see if I can do any better with this one than I did with 97 last time. Once again, I'm going to start with, should be straightforward, a sine plus a sine, which is the first one. Twice sine of the average, cosine of difference divided by 2. So I should get twice a sine 45 degrees add 15 degrees divided by 2. Cosine of 45 degrees minus 15 degrees divided by 2. Twice sine, that's going to be 60 degrees divided by 2. Cosine of 30 degrees divided by 2. This is going to give you twice a sine of 30 degrees. Cosine of 15 degrees. How am I going to show that's equal to a sine of 75 degrees? Well, a sine of 30 degrees is a half. So basically, it comes down to showing that a cosine of 15 degrees is equal to a sine of 75 degrees. I'm sure you can punch it directly on the calculator. I can show you that. Yeah, they are directly equal. Now, what's the easiest way to show? Probably a cofunction identity. Yeah, that's probably the easiest way. I don't know if you remember those cofunction identities. Probably have to reach back to another section. Were they in 7.1? They might have been the first page of 7.1. Yeah, here they are. Okay. Now you can take pi over 2 to be 90 degrees. We're in degree mode on this one. I need a cosine. So take a look. A cosine, it says a cosine of pi over 2, if I can put it up there again. Come on. Oh, I can get it. Okay. You can take that pi over 2 also to be 90 degrees. A cosine of 90 degrees minus x is equal to a sine of 90 degrees. Or is equal to a sine of x, I'm sorry. Cosine of 90 degrees minus x equals a sine of x. All right, so let's see if I can apply that to this. So I can write this as cosine of, I want this to be my x. See how 15, cosine of 90 degrees minus 75 degrees. Okay, that's equal to my 15 is 90 minus 75. This is my x. So a cosine degrees minus x is equal to a sine of x. This is 75 degrees and this is 75 degrees. Oh, I'm off the sorry about that. So I can write 15 as sine of 90 minus 75. You could also play on this side, right? That is sine of 90 minus 15. All right, but I'll play on this side since I started on this side. So 15 is 90 minus 75. That makes 75 my x. And so that cofunction identity says this is equal to the sine of that x, which is the sine of 75. Hence, cosine of 15 degrees does equal the sine of 75 degrees. And again, you can punch it on the calculator. It essentially means, if you want, that at 15 degrees, your x leg at 15 degrees, your x leg here at 75 degrees equals your y leg there. The x leg at 15 degrees equals your y leg. And in fact, there's nothing magical about 15 and 75. This occurs as long as the two angles add up to 90 degrees. The x leg on the one angle will equal the y leg on the other angle. That's all it's saying. It makes perfect sense to me. All right, that's probably enough problems. You're probably out of patience. We're not quite an hour. We'll call it for today.